Hi everybody, welcome to our virtual classroom, which is actually my kitchen and dining room. I just want to first say I hope that you had a great spring break and that you are safe and you are healthy, because we are thriving in this quarantine. Let me introduce you to our new co-teacher for the class. Come here, come here, come here. Good girl, come here, come here. Everyone, this is Lady. Lady is so excited to learn math with you. So, as we go through this virtual learning process that's new for everybody, just be like Lady and be patient, ask questions, and take a lot of naps if you need it. So we're gonna get through it, so let's get started. So the last time that I saw your beautiful faces, we had just finished the unit for graphing quadratics. We are now switching gears and we are gonna start solving those quadratic equations that you guys graphed, which sounds a little bit intimidating, but again, we're gonna make it through this. So we're gonna start out with factoring. And the first question in your notes packet, says, why is factoring important? Rather than write this out, factoring is just an easy way to break down a quadratic. So when we break things down, it does make it a lot easier for us to solve or to use it in other purposes like modeling and so forth. So factoring is just a fancy math term for breaking something down. So the first thing that we're gonna do is something that you guys may be familiar with, which is factoring by the greatest common factor. And I gave you the definition here. The greatest common factor, which it's abbreviated GCF, is the largest whole number that divides evenly into two or more numbers. And I posted also a factoring sheet that has a number and then it tells you how many factors. So for example, let's pick a bigger number. So 20 has 1, 2, 4, 5, and 10 and 20 because 1 times 20 is 20, 2 times 10 is 20, and then 4 times 5 is 20. So this factoring sheet will probably be your best friend for the next few days while you are figuring out and remembering your multiples, because you know, spring break was a week. We probably forgot all our math. Just kidding, I really hope not. All right, so back to our greatest common factor. We can apply it to polynomials, which you guys are familiar with now. But a GCF is the largest term that can be divided evenly between those terms. So terms, if you remember, include numbers, but it can also include variables. So let's take a look at some of these examples back here. Here we go. All right, so I'm gonna zoom in a little bit to number 1. So I probably won't do all of these examples. I'll probably just do this odd side for now. But email me if you guys need some more examples done. So again, number 1, we're starting out with negative 100 x to the 4th and then this positive 70. So 170 have something in common. They don't have x in common because 70 doesn't have an x. So I'm going to ignore those x's for now. So 170, since they both end in 0, I know that they're at least divisible by 10. But can you guys think of a number that's bigger than 10 that they have in common? Lady, how about you? No? She says no. So we're going to go with 10. So I'm dividing both of these by 10 because that is what I am taking out. Okay, so if I take out a 10 from negative 100, that leaves me with negative 10. But what was still with it? That's right, this x to the 4th. Okay? And then I have 70 divided by 10, which would be a positive 7. So really, you could think of factoring as undistributing, because if we distributed this 10, we should end up with our original problem that we started with. So this right here is our factored answer, and 10 was our greatest common factor. All right, so let's do another one. Let's do one that has variables. So as you can see on number 3, b to the 3rd and b squared, we know that they have b's in common. Now the question is, how many b's do they have in common? All right, so I'm going to start with the numbers, because for me numbers are the easiest. So 40 and 10, once again they both end in 0. Which means they actually could be divisible by 5, or they could be divisible by 10. But 10 is the greater number, and remember, we want the greatest common factor. So since 10 is the highest that they can both be divided by, that's the number I'm going to divide both of these terms by. Now, this exponent means that there are 3 b's with 40. But this one only has 2 b's because our exponent is 2. So they share 2 b's. Because this one doesn't have 3. It only has 2. But this one does have 2, but it also has that extra one. So when you're taking out variables, you have to take out the number that's the lowest that they have in common. So it's kind of the opposite of our coefficients here, where we want the biggest number they can be divided by. This one is the lowest that we can divide, which is 2 in this case. So if we do that, that means 10b squared is on the outside of our parentheses. And then we have 40 divided by 10, which I know is 4. But like we said before, this guy had 3 b's, but we're only dividing out 2 of them. So we actually have 1 b left over. Now, you can put the little 1 exponent if you want, but we know that we don't necessarily have to have that. Now, this time we have negative 10 divided by 10, which is negative 1, so I'm going to put minus 1. Now, b squared and b squared, when they're the same on top and bottom, I know those cancel out, so there's no b's left with negative 1. So there is our factored answer, with 10b squared being the greatest common factor. So as you can see, we've done 2 of them that had 2 terms. So let's up our challenge a little bit more, and let's do one with 3 terms. So we have 7, negative 14k, and 21k squared. So the first thing, again, that I'm going to focus on is the number. So 7, negative 14, and 21. What do they have in common? Hopefully you decided on 7. Each of these numbers are divisible by 7, and that's actually the greatest number they're divisible by. Now, the next question I'm going to ask is, can we take out any k's? If you're looking at this, do they all have k's in common? Hopefully you were thinking no, because of 7. 7 did not have any k's, so therefore they don't have k's in common. All 3 of our terms had to have k in order for a k to come out. So in that case, 7 is the only thing outside of our parentheses. So now I'm just going to do the dividing process again. So 7 divided by 7 is 1. Negative 14 divided by 7 is negative 2. But since I did not take this k and divide it, it still stays inside. Okay, and then 21 divided by 7 is positive 3. Once again, we did not divide any k's out, so this k squared has to stay inside as well. So our greatest common factor here was just that lonely 7. No K's, because they did not have them all in common. All right. And then we have number 7, which has 4 terms. So in order for them to have something in common, we need each one of the parts to have it. So 16, 32, 56, and 72. What do they all have in common? Well, I'm going to start with 16 and 32. I know 16 and 32 can be divided by 16. But can I divide 56 by 16? So no, I can't divide 16 by 56. And I also can't divide 72 by 16. So now I need to come up with another number that they can be divided by. Well, I know 16 is 8 and 2. So I'm going to go with the greater number first, so 8. Can 32 be divided by 8? Yeah. 56? Yeah. And 72? Yes. So, therefore, my number is 8. Okay. So again, this is where that factoring sheet that I showed you at the start will come in handy, because you'll see that each of these had 8 in common. So if I start with 16, you see there's 8 there. Then I move on to 32, which has 8. And then I want 56, which again has 8. And then 72, which again has 8. So you're looking for that number that they all have. So in this case, 8. Now, once again, can I take out these with this group? No, because of this dang 72 right here, he doesn't have any, so they don't have it in common. So that means the only greatest common factor they have is that 8. So I'm going to leave that 8 there, and then I'm going to do my dividing. So 16 divided by 8 gives me 2, and again, this v to the 4th stays there because we didn't take any out. Okay, then we have negative 32 divided by 8, which is going to give us negative 4. And then again, v squared gets to stay the same because we didn't take any v's out. And then 56 divided by 8 is a positive 7, and then v stays. And then negative 72 divided by 8 is negative 9. So if you notice, once you get your answer, 2, 4, 7, and 9, the only number that they can all be divided by is 1. So that's kind of a trick to know that you have the correct number here. So once you get all your numbers where they can only be divided by 1, then you know that you picked that greatest common factor. All right, so let's pick one more to do where we had variables in common. So let's go to number 4 on your notes. So we got 10, 30, and 30, which again, they all end in zeros. So I should be pretty straightforward with tens. But my question now is, how many p's do they have in common? Because this negative 10 has 6, this positive 30 has 5 p's with it, and this negative 30 has 4 p's with it. So the most that I can take out is actually that smallest number. So p to the 4th is what gets to come out. Because I can't take anything bigger than 4, because 4 obviously doesn't have any more. So 4 is the number that gets to come out for the p's. So if I divide these two, negative 10 divided by 10 gives me negative 1. And then if I had 6 p's here and I divided out 4 of them, that should leave me with 2 left over. Excuse me. It's not Corona, I promise. All right, so 30 divided by 10 is positive 3. And then I have 5 p's, but I took out 4, so that should leave me with just 1 lonely p. Okay, maybe I do have corona. Who knows? I'm totally kidding. Don't tell your parents that I have corona, because I don't. But I do have seasonal allergies, so hence the coughing. All right, sorry. Anyway, negative 30, we're dividing that by 10, so that's going to give us negative 3. But again, we're dividing out those P4s, which end up canceling on that guy. So negative 3 is all by himself. So if you are taking out variables, in one of your terms, those variables should cancel out. Whether it's the first one, the last one, the middle one, it doesn't really matter where they cancel out, but they're going to cancel out, and one of your terms is not going to have any variables. So here is our answer for number 4. So you're going to do this for a couple of days, and I will try to find another video to post that is related to this, just so you don't necessarily have to keep listening to my voice and you see some more examples. But hopefully this wasn't too confusing, but if you do have questions, again, feel free to email me, and I will try to clear up as much as I can. So good luck.